and nice meeting all of you in this event. And actually, since the morning, we have been listening to a lot of talks about the labeling business, which is very interesting, generative AI as well, and so on. Today, I will speak a little bit about a different topic, which is the AI platform. So from the hardware point of view, from the SDV point of view, the in-vehicle platform, how to enable AI inside the vehicle for autonomous driving. So my name is Hossam. I'm the CTO of Bright Skies, which is actually an engineering service company based in Egypt. And out of Bright Skies, we have a spin-off that's called BrightDrive, and I'm leading BrightDrive. Okay, so should I use this one to? Okay, thank you very much. So again, Bright Skies, we're an engineering service company. We have more than 400 employees. Started 2012, I think 13 years ago. Worked with most of the OEMs and Tier 1s in the world. I'm just listing here some of the examples, mainly based in the US. Okay, and BrightDrive, again, this is a spin-off from Bright Skies that is very much focused on self-driving. We're actually working on two main product lines. The first one is the platform itself, which is all the hardware and base software. And the other one is the application of self-driving. We had multiple pilots, as you can see. We started the first one in Egypt. A second one was a level 3 self-driving car, the red one. It was deployed in Saudi Arabia. And the third one was a bus, where we now focus on buses and trucks. And this was deployed in Dubai. It went to the Dubai self-driving competition. We won the second position. Hopefully it was the first, but we didn't have a very nice looking bus. So we trust our technology, but the prize was for the complete solution. Okay? That will be my topic for today. Hopefully I will not spend the whole 30 minutes. I know it's my last session before lunch. And actually it's the second event in a week where I'm the last one before lunch. Okay? Hopefully I'm opening your appetite for lunch. So I will speak first about the market. So my presentation today is about how to take ADAS, which we see today in, I would say, mass production cars. So if you go through San Francisco, you will see two kinds of vehicles. You will see the Waymo, self-driving ones, which are robotaxis. I would say very expensive technology, very good technology, working at level 4. And you will see also the other mass production cars, which are mainly at level 1, level 2, level 2 plus, and so on. Our talk today would be how to take those ADAS, level 1, level 2, level 2 plus, to full autonomy as well. We will start with some market review, and then we will speak about the technical challenges, and then I will speak a little bit about our platform that we call QuantumDrive. Okay? Oh, sorry. From the market, I remember a very interesting presentation today in the morning by Daniel. So I was speaking about 200 million cars expected by 2030. So this is actually a study for the ADAS-equipped vehicles, okay? So 5 years ago, by 2020, 10% of the vehicles in use in the world included ADAS systems. How many vehicles in use? We had almost 1 billion vehicles in use. So 10% is actually 100 million vehicles included ADAS. And this number is expected to grow to be like 30% this year, and then 50% by 2030. We are expecting a big growth of the percentage of vehicles that are equipped with ADAS. So the market is really booming, okay? But what level of ADAS are we speaking about? Are we today at which level? So some studies about China, about United States, mention that, okay, almost 50% of the ADAS-equipped vehicles are at level 2. Okay, it's pretty the same between China, between United States. In Europe, there are some OEMs who claim level 3 features. I would say not in a complete trip, maybe in a dedicated ODD. So mostly we are at level 2. Is it the highest level? Not really. The highest level is like level 2 plus, maybe plus, and so on, okay? So it's all about assisted driving, not fully autonomous driving. What we expect actually at BrightDrive and what we see from the market is going into more higher content of the ADAS features. So not really going for the simpler features, but going for the higher content of the ADAS. We have seen a supporting statement from Mobileye last year that was they have seen a recent, rapidly developing OEM trend towards advanced, higher content ADAS and for the mid-priced, high-volume segments. So actually, they are copying what we say. They are expecting also the market to go into more higher content ADAS. Some studies from McKinsey says, okay, maybe in 10 years, we'll go to a market that is like $300, $400 billion for autonomous driving. I'm not sure of this date. Maybe this date will shift a little bit. But the fact is we're expecting the market to grow from ADAS to full autonomy in some years, okay? So the situation today, we are at level 2 plus. We're expecting the market to go higher. What is limiting people to go higher? Why don't we see level 3 and level 4 tomorrow? So if you just think what kind of technical differences between a level 2 system and a level 4 system, you know the answer. Before we go into this topic of the technical differences, let's also remember what kind of vehicle architectures do we see the ADAS in. So usually you can find vehicles with ADAS like in a domain controller. So an ADAS domain controller is a big part of the business today. The other part of the business is what we see in zonal architectures, like what we see in Rivian cars, for example, that Volkswagen just I would say, invested in to get their zonal architectures. And the market for zonal architecture is growing. So we started to see already OEMs like Rivian, like Tesla, BYD, NIO, Stellantis, all these OEMs are delivering today zonal architecture-based vehicles. According to SAE, it was expected to be like 2% of the market share a couple of years ago, growing to like 38%. I'm expecting it today to be something around 5%, and hopefully projects for the next 3 years are mostly going towards the zonal architecture, especially after Volkswagen investment in Rivian. So what kind of zonal architecture? Is it like one size fits all? Not really. This is also a study from McKinsey. This is also confirmed from what we see in the market. There are different translations of the zonal architectures. Some of the OEMs, they only use one central computer. Others use 2. Others use 3. Okay? You can see from 1, 2 zonal controllers to like 4, 5, or even 6 zonal controllers. Zonal controllers can be like front and rear, or can be like 4 corners, or any different combination. So there are different translations. So sometimes you will see a dedicated central computer for ADAS, another one for infotainment, another one for powertrain, or maybe one for the other vehicle features. Okay? So we come back now to the technical challenges. Why don't we see level 3 and level 4 cars hopefully next year or the year after? We actually, I think Hisham, the German events were a couple of months ago, yeah. So we went to multiple events in Germany. We have been speaking with multiple OEMs, with multiple tier 1 suppliers. And we started to verify how much data rate are you expecting for every level of autonomy. And this is simply the result that we got from the workshop that included multiple OEMs and multiple tier 1 suppliers. Something like a level 2 plus system would include 3, 4, 5 cameras, maybe a couple of radars, and sometimes no LiDAR. Maybe they can use 1 LiDAR. Okay? With such kind of configuration, you speak about 4, 5, maximum 6 gigabits per second in real time. And all of this is feeding, for sure, is fed, sorry, to the AI system in the vehicle. If you go to the level 3, you have much more cameras, maybe a couple of radars extra, and mostly you will use a LiDAR in this case. Okay? You're speaking here about 10 plus gigabytes per second, maybe up to 15 gigabits per second. If you want to go to level 4, like what Waymo is doing, like what Pony AI is doing in China, you need to go to 20 plus cameras, maybe 5 plus radars, and 4 plus LiDARs. In this case, we speak about 20, 30, or maybe up to 40 gigabits per second. So just try to imagine today if you have a customer or if you have an OEM who is deploying a level 2 plus feature that is handling maybe 5, 6 gigabits per second in real time. Can they scale with the same technology, with the same platform? Can they scale to level 3 and level 4 easily? I think the answer is not yet. They need to define a completely different technology, different processors, different data pipelining to be able to handle this amount of data. And it's the same for the SoC, for the system on chip, that is really doing the real-time machine learning analysis. So level 2 plus systems usually use SoCs that are in the range of 4 to 8 tera operations per second. Can be teraflops or tera operations per second. If you go to level 3, you would start a little bit above 8, 9, 10, up to maybe 30. If you go on to level 4, speak about NVIDIA, Qualcomm stuff, and so on. So you go definitely above the 100 tops. So again, it's the same answer. A system today that is based on 4 or 5 tops of performance cannot really scale to handle 200, 300 tops of performance. Even if you add more SoCs, third, fourth SoC, it will not scale to this level. From safety point of view, it's also clear that for level 2 plus, you can find processors that can be ASIL-B compliant. If you want to go to this level of level 4, maybe 500 tops, it's not easy to find a chip that is completely qualified, but you can make a complete qualification on the system level, not on the chip level. So again, the summary here is that ECUs or electronic control units designed for level 2 plus cannot be reused again in higher level of ADAS. So it's not the same data rate, it's not the same processor, then it's definitely not the same technology. Okay. Don't forget something that is very important. The trend today for level 3 and level 4 is going for central computing. If you speak with guys from Mercedes, from BMW, from VW, they will all speak about everything has to be done in the central computer, okay? Which means too much heat, because now we have something like 500 tops in the central computer. So heat is increasing, cooling would be an issue, and also functional safety and cybersecurity would be a challenge. Availability would be a challenge. From safety point of view, you definitely have a single point of failure here. So I would say this definitely works, but would it be the best alternative? Would it be the best decision for OEMs to go to? I'm not really sure. Especially if you go to this solution, this doesn't work for level 2. If you go for solutions for level 2, they don't work for level 4. So you have completely 2 islands, 2 worlds that are not connected. What we are proposing here today is something that hopefully starts from the level 1 and scales up to level 5. And this is the mindset behind this platform. This is QuantumDrive that we launched earlier this year. And it's simply an ADAS and autonomous driving platform. It is designed to fit in multiple vehicle categories, whether it's a small passenger vehicle or it's a long bus or a truck, because it's designed originally for the highest level of autonomy, level 5, and then you can scale it down to level 2 and level 1. Okay, again, we focus on power efficiency. We use a zonal architecture. And for sure, compliance with 26262 and cybersecurity are, I would say, main enablers here. The mindset here behind QuantumDrive is about distributed computing. We're using the zonal architecture, not in the central computer approach, but actually, we thought that if we do everything here in the middle, we will have the same issue of very high power consumption, single point of faults, and so on. But what if we distribute the load to those zonal controllers? This is what we actually are doing right now. We are doing all the AI stuff at the zone controller side. That's why we have innovated what we call a smart zone controller. The typical architectures that you would see today at the big OEMs, they're using traditional zone controllers, which are simply gateways that take signals, convert them into services. We're actually not using this approach. We're using a smart zone controller, which includes an AI accelerator, which is doing all the object detections, okay? What is inside the platform here is a network of Ethernet connectors, so you don't really find any harness, you don't find any high bandwidth of data. All the high bandwidth of data is consumed at the zone side. And then what is detected here Simply an object list is communicated to the central computer. Okay? What are we doing at the smart zone controller? Simply you are doing all the pre-processing from cameras, from lidars, from radars. We're doing all the synchronization of the sensors, which is not an easy job, by the way. If you have 4 zones in your vehicle, every zone is connected maybe to 5, 6 sensors. You want to synchronize all those sensors together. Okay, so you want to have all the measurements synchronized to one common time base. We're doing also all the object detections, sensor fusion, road detections, tracking, all for the same field of view of the zone. Okay? This is our zone controller. If you pass by our booth, you will find a demonstrative version that you can maybe inspect in more details. We're using here in the, oh, sorry. Let me come back. We're using here in the central a machine learning SOC from SEMA AI. Actually, SEMA is based here in the Bay Area. And it's kind of a startup, but they are delivering a very nice SOC that is 50 tera operations per second, which is very much enough for the loads that we need at the zone site. So for one zone, 50 TOPS for us is the ideal, I would say, range to play with. And then we augment with a safety microcontroller for all safety-related stuff, so interface with the vehicle side, all safety requirements, synchronization. And we have an interface here for IOs that are doing sensors, power, sensor triggering, and so on. So we can connect this zone controller to up to 9 sensors. 6 high-speed sensors, Ethernet high-speed sensors. We have tested this with 5 megapixel cameras. We have tested this with 128 LiDAR channels. And we have tested this, I would say, with radars as well. You can also connect up to 3 high-speed CAN radars. So one zone controller, up to 9 sensors. So what's happening at the central node then? If the zone controller is doing all the object detections and everything, the central computer is mainly about detecting the 360 environment model. And then the OEM can integrate their own functions for driving. So all the driving functions that may be AI or may be deterministic software can run on the central computer. So about 360 detection, this is very simple. If every zone controller can see and translate and understands everything in its field of view, then simply the central node is responsible for augmenting those different fields of views into one 360 environment. I know it's not that simple because there will be objects moving from one zone to the other zone. There will be occluded objects. So we have all those stuff for cross-zone tracking, occluded object detection, and so on. Now going more into the SDV architecture, the software-defined vehicle architecture. Now this is very nice. Okay, you have a central computer, you have multiple zones, but what is the mindset of the software here? The mindset is we need to adopt an SDV approach, which means that everything in the vehicle features have to be defined, updated, configured, everything using software. The architecture has to adopt service-oriented architecture. Okay, every OEM can have their own OEM-specific middleware. And something that's very important, some OEMs will come to us and say, okay, now you keep all the raw data at the zone sites. We still need to have access to those raw data. It is not enough for us to access only the object list. How can we access the raw data? And actually, we give them a very simple answer. We don't need to move the data to the central node. We just simply can move your own application, your own service to the zone site. So every service, whether it's an OEM service or it's a platform service, can be configured to run either on the central node or on the zone controller. Because now you have an AI accelerator with also ARM cores at both sides. This is simply our proposed SDV architecture. We're actually partnering with Vector Informatique to implement this. So Vector is providing the adaptive AutoZAR. We're actually using here the adaptive AutoZAR stack. So on the cloud side, we're expecting every OEM to have their own, what they call software factory or vehicle application manager. which provides updates for the applications at the vehicle side. At the same side, you should have something like a diagnostic manager, which is responsible for data collection and diagnostics. So both are actually connected and transferred to the vehicle through MicroZar Connect, which is a component from Vector. Yeah, thank you. And this is communicating with the vehicle side. You have here the vehicle update manager for software updates. You have here the diagnostics over the SOVD, and you have all the services that we provide here in Blue to abstract the sensors, to provide the perception objects, and on top you have the OEM or even the Tier 1 services, driving functions. Okay? Again, one very important feature is the capability to configure services to run either on the central node or on the zone side. An example here is an emergency braking, actually. Just imagine here you have an emergency braking function that requires information from a radar and camera. In traditional architecture, you would receive those sensor information, move them back to the central node, do the logic, decide that we need to make emergency braking, send it back to the zone controller to command the actuators. In our architecture, we can simply configure Vector DaVinci so that the service of the AEB can run here on the zone controller. There is no need to move the data here. So all raw data exists here. The AEB can access data here and can command the actuators immediately from here. This is very crucial for timing critical safety functions. Okay. I have only 2 slides left, which is the road going from ADAS to ADS or to full autonomous driving systems. Simply, what we see is OEMs would start with very simple ADAS features. That is mainly, if you go to Europe, there are now laws and regulations for homologation of new vehicles. It's mandatory to have ADAS features. So the first level is to have ADAS features for EU regulatory compliance. And then usually OEMs go to the next level, which is level 2 plus, something like a lane change maneuver or highway pilot maneuver, something like this. And then you go to a level 3, which is hands-off driving, but still eyes on. And then you go to level 4, which is hands-off, eyes off. What we propose here is that using QuantumDrive, we have this configuration. So actually, our smart zone controller can handle up to 10 gigabits per second, up to 9 sensors, which is much more than enough for level 2 plus. In this case, it's very similar to the ADCU or the ADAS domain control unit approach. Okay. If you go to level 3, it's the same smart zone, but you add another smart zone with a central node. If you go to level 4, you need to have a central node, maybe 4 smart zone controllers. That's it. Maybe it's time for quick questions and then lunch. Just to mention that I want to thank also my colleague Mahmoud, who worked together on this presentation. He was not able to join me today because he is actually developing and delivering an autonomous bus in Austria this week. So I'm just giving this presentation instead of him. Thank you very much.
Thank you. So, immediate question over here from the floor.
Yeah, you.
Do you want a microphone?
Hi, thanks, Hossam.
Thank you.
That was a great presentation. It's good to see you guys making so much progress in CES.
Thank you. Yeah.
So I'm curious, what is the price target that you have for your zonal controller? And is that something that you are manufacturing in-house, or do you work with a technology partner for it?
Okay, that's a very good question. Zone controller today, we design it in-house, and we don't manufacture in-house. We don't have a manufacturing facility today, so we do it at a contract manufacturer, but we design it in-house. The target price point is not really, I would say, very clear, but we heard a lot from the OEMs. We heard that for sure, if you want to go to level 2 plus, you need to go below the $1,000 or euros, and maybe even lower if you want to go to mass production. So it depends for sure on the volume. But yes, today we can meet this price point, and that's the very interesting point here in this architecture.
Yeah, that's great. That's sort of where we see things going at Zendar as well. This sort of like a L2 plus domain controller that is priced well below the 1,000 mark. Okay. But yeah, this was a great presentation. Thanks a lot.
Thank you very much.
I think we take this gentleman.
decentralized solution is not suitable for L2. Is that more of the business side of things where it's just too expensive, or is there some technical reason why it's not suitable for L2, but it is for L2 plus and above? Thank you.
Yeah, for sure, the centralized approach is designed to be, I would say, very data intensive with a lot of heat expected, so there will be a lot of liquid cooling and so on, so it's definitely very expensive. For level 2 and level 2 plus, price is very important point. If you remember my introduction about the difference between Waymo and the mass production guys, Waymo is doing great technology for a limited volume, so they can really go with price high, it's okay. But with mass production, every dollar matters. So that's the real point.
So it's really more the business side of things and not
definitely.
the technical.
Yeah,
Thank you.
Definitely. Thank you.
I think we have time for at least one more question if anyone would like to ask.
Yeah.
Hi, thanks. Very good presentation. What about redundancies? How do you account for them in a zonal?
It's very important. Actually, there are lots of options for redundancy here. The first option for sure is the central node has to include redundancy, so 2 main processors with a safety node, and that's standard of in every zonal architecture right now. The second option that you can make is they can make zone controllers speak together. That's definitely an option, especially if you design them with an overlapped field of view. So for some parts of the field of view, especially the most critical parts, you can have an overlap of the sensors here and there, and then you can have redundant evaluation between 2 zone controllers. So yes, definitely it's possible. I would say this is to be customized for every OEM as part of their overall safety case. Yeah.
And time for one very brief question if anyone has a last one.
Yeah, please.
Do you accept SerDes link?
Sorry?
Do you have a SerDes link? Is that accepted within your controller?
I'm sorry, I couldn't get it.
SerDes.
SerDes.
Yeah. Do you accept this communication link?
Communication, serializer, deserializer, you mean?
No, I think I have my answer. Yeah.
I didn't get it, I'm sorry.
I didn't get it either, I'm sorry.
Yeah. If we speak about SerDes, I know SerDes in communications. Okay, that's definitely serializer, deserializer. So the first version that we have today is only based on Ethernet. That's because our machine learning stock includes only Ethernet interfaces. The next version, which is coming soon, would include an interface for high-speed MEBI, which is based for sure on SerDes. And then it would support GMSL cameras. Yeah. Hope this answers your question. Thank you very much.
Yeah, thank you.
Thank you.